Welcome to Small Code Learns. In this video, let's understand what OOPS and how it fits into .NET development. OOPS is a programming model based on real-world objects. It helps us write cleaner, reusable, and maintainable code. There are four main principles or pillars of OOPS: encapsulation, inheritance, polymorphism, abstraction. First, we will see encapsulation. What is encapsulation in OOPS? Encapsulation is a fundamental concept in object-oriented programming where data variables and the methods functions that operate on that data are bundled together into a single unit, typically a class. It also restricts direct access to some of an object's components, which is known as data hiding. Real-life example is ATM machine. When you use an ATM, you insert your card, enter your PIN, perform operations like check balance or withdraw cash. However, you don't need to know how your balance is stored, how it communicates with the bank server, how money is withdrawn from your account. Key benefits of encapsulation. 1. Data hiding access modifiers like private, public, and protected are used to hide internal details of a class. Example: you can check your balance, but you can't see how it's calculated or stored. 2. Improve security. Only specific parts of code can access or change sensitive data. Example: even if someone has your card, they can't withdraw cash without the correct PIN. 3. Flexibility and maintainability. Internal logic can be updated without affecting external code. Example: the bank can change how balance is stored, but the ATM interface remains the same. 4th, cleaner, modular code keeps code organized, reusable, and easier to understand. Example: you interact only with ATM buttons, not with the bank's backend or staff. Inheritance. What is inheritance? Fields and methods are inherited from the base class to the derived class. This promotes code reuse and establishes a natural hierarchy between classes. To inherit from a class, use the colon symbol. We group the inheritance concept into two categories: derived class child, the class that inherits from another class; base class parent, the class being inherited from. The real-world example, let's consider two different classes: base class animal and derived class dog. Dog does not have its own eat method, but dog inherits from animal, so it automatically gets access to the eat method. That's why mydog.eat works even though eat is not defined in the dog class. This demonstrates code reusability. No need to write eat again in dog. Types of inheritance. Single inheritance. One derived class inherits from one base class. Example: mechanic inherits from person. A mechanic is a person who has specialized skills. Multi-level inheritance. A chain where a derived class is inherited by another class. Example: a baby inherits features from the mother, who inherited from the grandmother. Hierarchical inheritance. Multiple classes inherit from one base class. Example: teacher and student inherit from person. Both teacher and student are persons, but play different roles. Multiple inheritance. It does not support in C#, but via interfaces. A class can implement multiple interfaces. Example: actor implements iSinger and iDancer. An actor can both sing and dance by implementing both roles interfaces. Hybrid inheritance. A mix of multiple inheritance and multi-level inheritance, often involving interfaces. Example: electric sports car inherits from car and implements iElectric and iSports. Combines a class chain with multiple capabilities using interfaces. Polymorphism. What is polymorphism? Polymorphism means many forms. In C#, it allows objects to behave differently based on their actual type, even if they share the same interface or base class. There are two types of polymorphism in C#: compile-time polymorphism, method overloading, or static polymorphism; runtime polymorphism, method overriding, or dynamic polymorphism. Compile-time polymorphism, method overloading. This occurs when multiple methods have the same name but different parameters in the same class. In this example, all three methods are named add, but they take different types or numbers of parameters. The compiler chooses the correct one at compile time. Runtime polymorphism, method overriding. This allows a derived class to override a method from the base class. This requires the base class method must be marked with virtual. The derived class method must use override. Animal defines a virtual method. Make sound, dog overrides this method with its own behavior. The decision of which method to run happens at runtime.
Abstraction. What is abstraction? Abstraction is the process of hiding complex implementation details and showing only the essential features of an object. The real-world example is, when you start a car, you press the start button or turn the key, you don't see how the engine ignites, how the fuel is injected, how the battery powers the system. Only the essential controls are exposed to you. 2 ways to achieve abstraction in C#: using abstract classes, using interfaces. Abstract class. An abstract class cannot be instantiated. It can have abstract methods, no implementation, and non-abstract methods with implementation. Child classes must override the abstract methods. In this example code, you cannot create an object of animal directly. It's meant to provide a common template for all animals. Make sound is abstract method. It has no body implementation in the animal class. It must be implemented, overridden by any class that inherits from animal. Sleep is a concrete, non-abstract method. It has a body and common logic, e.g., sleepin', that can be used directly by any subclass, like dog. Dog inherits from animal. Since animal has an abstract method, dog is forced to override make sound. Interface. An interface is 100% abstract. It can only contain method signatures, no implementation. A class that implements an interface must provide the implementation for all its methods. We can extend multiple interfaces in a single class. In this example, iVehicle is an interface. It declares a method drive without implementation. Interfaces cannot contain any implemented methods or fields except static const in advanced use. Car class implements the iVehicle interface. It must implement the drive method. When drive is called on a car object, it prints car is driving. A class can implement multiple interfaces, which is C#'s way to support multiple inheritance. In the next video, we will provide fundamental of OOPS with their code example. Please subscribe to Small Code Learns for more bite-sized coding tutorials. Thanks for watching.